So I wanted to show you the recording yesterday in the class, but Zoom has its limitations because not everyone has a perfect internet. So it was not possible for me to show the video because for most of the people, the video was just lagging. Okay, so today is third lecture of circular motion, and let me make that situation. Okay. Hey, can you please mute your mics and only open them if you have a question? Okay, so I'm gonna use this line to represent the bucket. Now this is my bucket and I'm spinning it like this. This is the bucket in the inverted state. Now, yesterday I asked a question and most of you got it right. I asked what would happen to water and it's not gonna fall off. And today we're gonna discuss why. I mean, I clearly showed you guys when I tilted the bucket and the water fell. So when I did the bucket like this, the water, it poured to the ground, it fell. So why is it that in this situation, the water doesn't fall? Now, before I do this, can you guys tell me what is the direction of tension over here? What is the direction of tension over here? Is it downwards or is it upwards? Come on, guys. Where is my tension pointing in this situation? So this is the center of the circle. Yeah, so exactly towards the center. That applies everywhere, and upwards is the right answer as well. So this is the direction of tension, and this is the direction of tension. Now, yesterday, for those who watched the video, for those who are in the class, I said that I can say that this is a pull, right? I can say that this tension, this is basically a pull, right? And I also taught a line. Now pay attention. I said that gravity opposes a push or a pull. And now if this is the pull, where is my gravity gonna be? And that gravity is gonna be my apparent gravity. That's not exactly. It's gonna be upwards. Now, this property of gravity, now this one statement is the explanation for why the water doesn't fall off. Yes, there's another reason as well. And I'm gonna tell you that reason as well. But for now, this is our main reason. This is the direction of our, perceived gravity. This is the perceived gravity. So the gravity knows that, there's a pull right here. This tension is a pull. And yesterday I taught that gravity opposes any kind of a push or a pull. Yes, I know gravity is acting downwards. So the weight, the weight is going to be downwards. The gravity is downwards. But since gravity, this same gravity opposes any kind of a pull or a push, I will have apparent gravity. So for this water right here, this water thinks that gravity, oh, just a second. Okay, so this water thinks that gravity is upwards. So for this water, everything is normal. It's just weird to our eyes. It's only for us that we are looking at it and the water is inverted. So for this water, the gravity is going to be upwards. But again, gravity is downwards. This is just, the perceived gravity. Is everyone clear about this? Because after this, I'm going to be explaining the second reason. Okay, that's amazing. So I'm saving the screen. And in fact, okay, yeah, I'm just gonna make this small. I'm gonna reduce the size, and I want you guys to understand what? Okay, all right, so yesterday, okay, so I have two questions right now. One question is the gravity of water molecules. The second question is what is perceived gravity? So allow me to explain by first telling you what is perceived gravity. So first of all, our gravity is acting down, it's acting downwards, right? But I taught yesterday that gravity opposes a push or a pull. So this is the property of the same gravity. So this same gravity that's pointing downwards it has a property of opposing any kind of a push or a pull. Now, allow me to give you one example. So yesterday I gave this example. Let's say this is the ceiling and this is a wire and I am holding the wire and I'm trying to impersonate Tarzan and I am moving in a circle. So why is it that my body is pointing towards that direction when the gravity is acting downward? So in reality, we know that gravity is downward. So why in the world is my body pointing towards that direction? Well, that's because we have tension here, and tension is a pull. So this gravity right here, our gravity, it opposes this pull, and that's why we have this perceived gravity. So, Rayan, do you understand what is perceived gravity now? So, perceived gravity is apparent gravity. It's gravity that's not actually there, but it seems like it's there. So it's just for our understanding. It looks to us as if the gravity is there, but this is the function, this is the property of our original gravity. So Rayan, please answer my question. You asked me what is perceived gravity. Do you understand now? Okay, so if you don't understand, you can still ask me. So now this was the first part. This is perceived gravity. Yeah, it's a form of a gravity. Now, moving on to Ima's question. So Ima's question was gravity of water molecules. Look, let me kind of reword it. In reality, as I said, there is no gravity there. So gravity is just where, so this is our gravity, right? This is where our gravity is pointing. This is the original direction of our gravity. So don't get confused. So this is a gravity. But as I said, that gravity opposes a push or a pull. This gravity right here, this gravity is going to oppose this pull right here. And that's why I'm going to make an arrow upwards and I'm going to show perceived gravity. So this perceived gravity, it's acting on the whole bucket. So this bucket and the water. So answering Ima's question, it wouldn't be just the water molecules. It would be the whole bucket. Do you understand now, Ima? Okay, great. Now, I'm going to erase this. I'm going to clear this. Okay, so now I want to explain you guys how centripetal force works. Now, I don't know if people in other countries do, but especially in Pakistan, in our childhoods, we used to play this game. So we had two hands, and let's say this is my arm, and the second person, okay, the drawing is going to be kind of bad, and no problem. So there's going to be the second person. The second person is going to hold my hand like this, and we are going to spin. So let's make the head and the body, the head and the body. Okay, so now we used to spin ourselves, right? Does anyone remember this at all? So we used to spin ourselves. Yeah, exactly. We used to spin ourselves, and then when we stopped spinning ourselves, our head, our eyes, the whole world would be spinning for us. Now that's another topic. So what I want you guys to understand, when we are spinning each other, when that person is holding, let's say this is person A and this is person B. So person A is holding person B's hands and person B is holding person A's hands. And both of them are rotating each other, they're spinning each other. And for those who have done this, doesn't it feel like as if something is pushing your body towards that direction? When you are spinning each other, doesn't it look like if you let go of these hands, you're gonna go fly off to New York? I don't know. You're gonna go fly off to New York because it feels like there's a force that's kind of pulling us from this position. It feels like something is pulling us. Now, I would like to add another example to this concept and then it's going to click. Okay, so let's leave this concept for a second. So how many of you guys have used automatic washing machines? Has anyone used it ever? Automatic washing machines. So they look like this. If anyone hasn't, then it looks like, I mean, everyone has. So this is what it looks like, right? So I hope you guys have seen this before. So there's a lid over here. I don't know what it's called again. So you place your clothes inside of it, and you start a button, and let's say this is start and this is stop. Now, my teacher was telling me something amazing. So when he was a student, he went to the United States, and one day he literally had $5. So he placed his cash into this thing right here, and when he started the machine, his clothes disappeared. They literally disappeared, and he got scared, and he was like, "Oh my God, that's all the money I had. Where are my clothes?" So he got scared and he was shocked. Where were his clothes? Now, when he stopped the machine, when he clicked the stop button, surprisingly, all the clothes appeared again. Now, there's one very interesting thing. In washing machines, let me make it a bit better. So let's say this is how much, let's say this is what we can see. This is the lid part, right? This is where we open. And let's say this part, let me make it. Let's say this is the inside of the washing machine. So we cannot see this part at all. This part isn't visible to us. We don't know. Yeah, Varun, that's the explanation. We don't know what's inside of there. Now, uh, just like this, when you are spinning each other and it feels like something is pushing you away, something is trying to get you out of that motion, same thing happened with clothes. So let me make it first. Okay, so imagine that these orangey thingies are your clothes. So, oh, what did I do? Okay, so your clothes are spinning inside of it. Let's say this is the washing machine working in action and it's vibrating and all. And your clothes, they get pushed to the sides so much that it appears as if all of your clothes have disappeared. So to a person who's looking from here, it looks like your clothes have disappeared. Magic. But in reality, it's no magic. It's simple science. All the clothes, they get attached to the walls. So in reality, we're not going to talk about that force. I'm just going to explain you this as a function of centripetal force, but it appears as if there's a force pushing the clothes to the walls. And a fun fact, what is the function of a washing machine? Let me erase this. So a washing machine is used to basically wash the clothes and dry the clothes. So let's say we have water over here. Now, in this place, now pay attention over here. I'm going to make some small holes to show, yeah, so these are our small holes in the washing machine because we know there's holes, right? It isn't just a black circle. So there's a lot of holes here. Now we know that the clothes are wet, right? So the clothes are wet and the water is obviously also going to be pushed away. So what scientists did was they designed this machine in such a way that the clothes, they just get attached to the walls and the water, it flows off through these holes. And when we open the washing machine again, when it's done, the clothes are dry. So the water, it gets, it escapes through these holes because there's holes, and this circular motion, it is pushing the water away. So if we didn't have this circle, the clothes would fly off to another city. I mean, not literally, but they would fly off somewhere really far because circular motion causes that. Now, do you guys understand this washing machine thingy? The next time your mom asks you to put the clothes in the washing machine, so yeah, you could say that, Aima. So a force is pushing the water away. A force is causing all the clothes to move away. So if I were to make a circle over here, and if I were to enlarge it, let's say this is so the force causes the clothes to go away. So if there was no walls, let's say these blue thingies are the clothes, they would just go away really far. Now, let me actually explain what's happening in reality. Now, there's another example that I want to give. And this example is over now. Now, imagine, now it's going to be an example that I've used a lot of times, but we're going to look into it again. When you're holding a yo yo and you are spinning it, when you're spinning it, it also feels like that there's a force trying to take the yo-yo away from your hand. So if I'm holding, let's say I have my fingers right here, so it kind of feels like something is pulling, the string away from my hands, and the yo-yo seems to be, it seems to be there seems to be a force that's trying to remove the yo-yo from your hand. It's trying to pull the yo-yo away from your hand. Yeah, exactly, as if it would fall off. So now let's look into the actual phenomena. The reality is that's how centripetal force works. Now I'm going to explain you actual terminology. Yesterday, let me erase this first. Now pay attention. Yesterday I said that centripetal force is, okay, I'm going to give you guys a chance. I need the formula with the omega. What is the formula for centripetal force? Come on, guys. Yeah, it's the centripetal force. Yeah, exactly, what an amazing. So it's mr omega squared. Now, I said that omega is constant. So omega is constant and mass is constant. And I know that Fc is directly proportional to radius. That was one thing. And I also said that we also know that velocity and basically, let me rephrase it for a second. So yesterday I made that circle. I made this circle and I said that if I have, this was my A and this was my B. So B has greater velocity. So the further away I move, my velocity and the centripetal force increases, right? So this means that the greater my velocity, the greater my centripetal force. Now, I cannot make that relation because the formula doesn't support it, but let's imagine for a second. So we know that B has greater velocity and it has greater FC. Now, let's apply this to this situation. Now, look here. I was talking about turns yesterday. I was saying that if you're driving a car, now tell me one thing. If I'm driving a car and I slowly drive the car and I slowly turn, will my car skid? Will my car go towards this direction? Will it go there? No, exactly. It doesn't. It only happens when, in Urdu we say shararti drivers. So when we have the drivers who like speed. Okay, so we have one student called iPhone. Okay, so it only happens when your car has a large speed. So if the car has a very high speed, the car moves and it kind of skids. It moves in that direction and the car can crash. The car can crash. Now, why does that happen? I said that, let's say for a second, higher the velocity, greater the FC. Now, don't make this as a rule because it doesn't always happen. But in this scenario, it will happen. So I can easily say that just like in the turntable, B had greater centripetal force. Can I say that if I have greater velocity, I also need greater centripetal force? Can I say that? Can I say that if my car wants to complete this turn without slipping away, without skidding away, skidding is the actual term, it needs greater centripetal force, and that's the reality. So this means, you know why this happens? Well, I'm going to tell you now. This happens because the car wants to gain friction. We know, let's imagine, when we are turning, this is the direction of our centripetal force. So when we're turning, the car is actually, doing uniform circular motion. But since I don't have enough friction to maintain my centripetal force due to large speed, the car moves away to the right, because when it moves to the right, it gains friction, because we know more the contact the tires and the road make, greater the friction is going to be. So the car moves towards the right to gain friction. It wants to gain friction to maintain, to basically increase, to get greater centripetal force. The car moves towards the right to gain friction to get greater centripetal force. Aima, you just raised your hand. Do you have a question? Or was it a mistake? Um, yeah. So, uh, centripetal force to counterbalance. Are you talking about this scenario, or are you talking about the scenario of the bucket? This scenario. Okay, so you see here, we're not talking about gravity at all. So in this scenario, we are not going to talk about gravity. Gravity is going to come in later, later cases. So in this scenario, we are not going to talk about. Okay, no problem, no problem. I'm going to explain you. So, okay, so Rayan has a very interesting question. He says, "What if there's no friction or the surface is wet?" So Rayan, tell me one thing. Let me. I'm going to bring this back. Don't worry, I'm not clearing it forever. Let's say we have a circle. So let's answer this question first. Let's say we have a circle, and let's say I drip oil. So this thingy is oil, right? This thing is oil. Now, imagine that I have a car. Now, it's a very good question because it might clear up other confusions as well. Now, imagine that I have a car, a toy car. Now, tell me, if I want to do this motion, will my car ever be able to move in this circle? Or will it keep slipping, and it won't be able to complete the circle? Exactly. If I don't have friction and I have a car that's moving in a circle, it's never gonna get friction at all. And if there's no friction, there's no friction, there's no centripetal force, and there's no circular motion. So I will never be able to fulfill the circular motion. Okay, now let's move back. Just a second. Let me go back. Okay, now we're here. Okay, so the friction thingy. Okay, so let me say it again. When I was, okay, so when I had lesser velocity, okay, let's leave velocity for a second. Let's leave speed because it's going to confuse you more. Okay, so in fact, we might need speed after all. Okay, so when I was going at a slower speed, I needed lesser centripetal force, right? I needed lesser FC. I needed a smaller centripetal force to make my turn because I had lesser speed. But now I know that I have greater speed, and if I have greater speed, I need greater friction. I need greater centripetal force. So let's say for a second, let's assume. Let me remove this. Okay. Now pay attention because if you miss this, you're gonna miss the concept. Now, let's say the car is going at a normal speed, right? My car has a normal speed and it simply makes a turn. Now, let's say this thingy right here, this has a friction of, let's say, 10 newtons, right? Let's say the tires of the car and the road, they create a friction of 10 newtons. And this friction provides the centripetal force for my car to turn, all right? Now, so this means this is the maximum friction the road can provide with the car turning normally, with no extra, skidding and stuff. Okay, now let's observe. Now I have greater velocity. My car has greater velocity, right? So this means that if I have greater velocity, I won't have the same centripetal force. So if in the past I had a centripetal force of 10 newtons, basically a friction of 10 newtons providing this centripetal force. Now, let's say I will need, this is my requirement, this is my required centripetal force to make this turn because my velocity is greater. But I know that the road can only give me 10 newtons. Exactly. So where in the world am I going to get the other 10 newtons from? Well, the answer to that question is when my car comes here, let me make it in a different color. So when my car is over here, it will have to move towards that direction. It's going to move away to gain that friction. So the friction can increase to 20 newtons and then it can make that turn. Do you understand now? So we can say here centripetal force. Yeah, centripetal force is friction. Didn't I say yesterday that basically centripetal force is nothing? It's just a resultant force. In reality, this friction is my centripetal force. Okay, so I hope the one who asked the question. Okay, so Aisha says, explain again. Okay, no problem, Aisha. Okay, now tell me one thing. I'm going to give that example again. So you guys did that thing in your childhood where you, okay, let me do this for a second. Okay. Okay, so let's make that scenario again. Don't worry, I'll explain as many times as needed because this is a very confusing concept. So let's say this is person one, and okay, the drawing is going to be really bad. Okay, so the person is, has his hands. This is person one, and let's make person two. Okay, Legina, I'm going to answer it right after this. Okay, so the people are holding their hands. Okay, now they're spinning. They are making a circle by spinning each other. The people are spinning. Now, when you are spinning each other at a lower speed, let's say, very small speed, a small speed. So when you're spinning each other with a small force, so when you're not giving so much force, it doesn't really feel like something is pulling you to that direction, right? It doesn't really feel. It doesn't really feel that much. But it happens when you start applying a lot of force, when both of you are going mad, when both of you are giving every single strength you have, when you're giving all of your energy into spinning each other, it's only then that you guys feel that there's something that's causing you to move to that direction. Now, this thing, what is it? In reality, this is the centrifugal force, but we are not going to talk about it in A level physics because it's not required. But we are talking about centripetal force. Now, let's say this is my centripetal force. I'm going to use a red arrow. This is my centripetal force. In fact, let's use a green arrow because we already have a lot of red. So this is my centripetal force. Okay, so in the first scenario, we were not giving so much force. We were not really, applying that much force, and thus our velocity was also lesser. But when we're applying a lot of energy, when we are spinning at a very high speed, our centripetal force is gonna increase. So if we want to remain in this motion, we need to apply more power. So in this scenario, can anyone tell me what is providing the centripetal force? In this scenario, what is providing the centripetal force? We know that in this scenario, friction is applying the centripetal force. Friction is providing the centripetal force. Friction is the centripetal force. Now, my question for you guys is, what is my centripetal force in this case? What do you think? Yeah, that's what anyone would say. That's the normal answer. But in reality, this is the center of the circle, your hands. So your hands are, yeah, the hands. So you are applying you're applying that action. Basically, the action button is talking about that action is happening in our hands. So the friction between our hands. So Sabina, the thing is that this is not vertical. So this is all okay. So you could say that. You could say that. But perceived gravity is not the centripetal force. What I'm actually asking is, what is the centripetal force? So perceived gravity does come into this, but it isn't providing the centripetal force. Now, okay, so the centripetal force is being provided by the friction between the hands. So basically, the hands. Now, before it gets too confusing, which I know I already made it exactly. So, okay, this is a very good point. So the friction between our hands. Okay, thanks, Aisha. That's a very amazing point. I'm gonna mention it. Okay, so when we speed up a lot, it doesn't it feel like we're gonna lose the grip between our hands and we're gonna fly off into these two directions. Now, It's because we need greater centripetal force because our velocity is so high. Our velocity is so high that we need equal amount of centripetal force. Now, where is the centripetal force coming from? It's coming from the grip in our hands. So it means if I need greater centripetal force, that means that I need to apply more force in the hands. There has to be greater amount of friction between our hands. Our grip has to be stronger. So if we don't make our grip stronger, we are just going to fly off into those directions. And this thing right here, this feeling that something is pulling us, this basically happens because it will strengthen our grip. If something is pulling us to those directions, we will obviously want to make our grip stronger. So now let me contrast these two things. In this scenario, the car's tires want to gain friction. So the car moves to that direction because it wants to gain that friction. But in this scenario, our bodies are moving to opposite directions because they want to make the grip stronger. They want to gain that, centripetal force. Okay. Okay, so Rayan, that's the what force are you okay. So basically Rayan's question is what about the force that opposes our grip? Okay. Now this black force, in reality, we call it the centrifugal force. But we're not going to talk about it in A levels. So I am basically saying that this black arrow is a force. Basically, let me explain it in this way. Okay, so imagine, so you know that I will need greater centripetal force, right? I need a greater amount of centripetal force. Now, we also know that I will only get that great amount if my grip is stronger. Now, this force, just to explain you, imagine that this force is a force that causes our grip to become stronger. So, just for your understanding, understand it in such a way that this force causes your grip to become stronger. And if you don't make this grip stronger, you're just going to fly away. Now, but in reality, remember that a washing machine example? So that washing machine example is the same thing that is happening here. So that's the force. That's the force that kind of pulls us away, pushes us away. Now, for a second, I'd like to leave this for a second because it's getting too complicated. Let me move back to this scenario. By the way, guys, the time limit says that we have around 3 minutes left. So if our lecture suddenly ends, don't go anywhere. I am just gonna send you the link in the group. Okay, now, one of the students asked me, why is, okay, let me read the question again. So her question was, why is car's driving force not the centripetal force? Look, I know that centripetal force is pointing in this direction, right? So centripetal force is a force that's acting towards the center. And this arrow right here, this is not the direction of friction. This is the motion of the car. Now, the fun thing is, the fun fact is that my friction's direction is also towards the center. Why is it? That's not our concern. The direction of friction is also towards the center. But the direction of car's force, or the thing you're talking about, it's not towards the center. And it's not providing the centripetal force. But you should also know that when my car is moving in this motion, when my car is moving in this circular motion, that force you're talking about, that is the centripetal force. Okay, so this line says that this statement says that the objects tend to move out to gain the centripetal force. So the same thing is happening here. When my clothes are moving out and the speed of my washing machine is increasing, the clothes and the walls of the washing machine, their contact force is increasing. And so my centripetal force is also increasing. So the simple answer is that my clothes and the water, they want to gain centripetal force. And that's why they are moving out. That's why the water moves out from these holes, because it wants to gain the centripetal force. Now, there's a really fun thing that I'd like to mention here. So, if you have wet fruits, this isn't my idea. This was also told by our teacher. He did this when he was in his university. Now, imagine you have wet fruits, and there's these baskets, right? There's these baskets with a lot of holes. Now, what you want to do is you want to take two of these baskets, and you want to place the fruits inside, and you want to place the baskets like this. So my first basket is going to be black, and the second one is going to be red, like this. And let's say I have these holes, and this net thingy is protecting my fruits from falling away, but it allows the water to go away. Now I'm going to make the fruits in green. So let's say these are my fruits and they are wet. Now imagine that I have this thing, and I suddenly, okay, just a second. All right, so now what I'm gonna do is I am gonna rotate this. So this is my rope or wire or anything, and I am spinning it. Now when I spin it, the same thing happens. As my speed is increasing, the fruits and the water, they wanna gain centripetal force. So all of them they tend to move out. They tend to move and stick to the walls. So the fruits are gonna stick to the walls, and the water moves out. Exactly. The water moves out because it wants to gain the centripetal force. And so your fruits will be dried. All right. So what I'm going to do is I'm going to leave this concept now because we have done a lot of work on it. And I'm going to explain one thing. And we are going to do this concept. Okay. So in case anyone hasn't written this line, do write it, because it's the explanation for the stuff we have discussed for the past 15 minutes. All right, so I'm going to erase this now. Amazing. Okay. Now, we have invested a lot of time in the stuff that was supposed to be just conceptual, but no problem. Now we're going to do the real thing. Now, this is the actual heading in this chapter, the vertical circle. And this is where you're going to understand all of the stuff I've been teaching for the past 2 days. Now, we have a vertical circle, and this is very similar to the bucket scenario. And this might clear up a lot of. Okay. Centripetal force in the basket. Okay, the centripetal force would be. Okay, that's a very amazing question. So normally it would be the tension in the rope. It would be the tension in the rope, but that's a bit complex. My knowledge doesn't know, because we've studied the washing machine, and we have studied the yo-yo. So the basket diagram would be a combination of those two. So I'm gonna look into that. You guys can search in the internet as well. I cannot answer that question right now because that goes beyond my current understanding. Okay, so we have a vertical circle, and it's very similar to the bucket thingy that I did. Now, imagine that this is again a rope and a ball, and I'm spinning them, and I am in this motion. So I have 2 points. I have point A and I have point B. And whenever I have a rope and I have something that I'm spinning, my centripetal force is provided by a special thing. Now, what is going to be my tension? Where is going to be my tension? You guys answered it before, but just to check if everyone knows. What is going to be the direction of my tension here and here? Is it going to be upwards or is it going to be downwards? Okay, yeah, B is going to be up and A down. Amazing. Yeah. Now, I can easily say that this is TB, and I can say that this is TA. Just a second. Yeah, that might be the actual explanation, but as I said, I'm gonna look into that. Okay, now I have tension, but we also know that we have weight. Now we have been talking about perceived gravity for 2 days, but now we're gonna talk about actual gravity, actual weight. Can you tell me what is gonna be the direction of weight over here? Is it gonna be upwards or is it gonna be downwards? I mean, it's a very obvious question, so you guys should answer the right thing. What is going to be the direction of my weight? Come on, guys. Exactly, down. That's a very obvious answer. It's going to be down. So the weight is going to be down here, and it's going to be down here as well. So for both A and B, my weight is down. Now it's a very fun thing that we're going to do. I'm going to make two headings, and it's going to click. It's literally going to click. So at A, can you guys tell me what is providing the centripetal force at A? What is the cause of my centripetal force? I have been teaching you guys that centripetal force is a resultant force. So, what is providing the centripetal force at A? Can anyone tell me? Yeah, that's the right answer, but it's not it. There's something else. Exactly, Aisha. That's the right answer. So, in all of the scenarios before this, I have only talked about tension, but now we have both of these. So if anyone said weight or tension only, that's not the right answer because it's both of them. And we know that centripetal force is basically the resultant force. So it isn't necessarily just one force. So you can see I made a double arrow, and this is my centripetal force over here. And we know that centripetal force is any force that's acting towards the center. So my FC is gonna be W plus TA. Is everyone clear about this? Because it might have confusions. Okay, that's amazing. Now, if I say that I want to know, now it's going to be even more fun. What is my FC at B? Can anyone tell me? What is going to be my centripetal force at B? Exactly, Lagina has the right answer. So the first step is make an arrow towards the center. Now resolve the forces. So it's going to be TB. It's going to be TB minus W. Okay, I have a very interesting question for you guys. Is the tension okay? It's my question. All right, so no problem. Is this right? Is this right or is this wrong? Are both of tensions equal? Can anyone tell me? Is tension A equal to tension B? Okay, so your answer is yes. Now I am gonna surprise you with something amazing. Okay, so let's look at this. Can you guys tell me what is gonna be tension A? I mean, it's basic math. Okay, so I think Aisha has her eyes open now. Okay, so what is going to be my tension? Come on, it's basic math. Look at this. Come on, basic math. No, I don't need the numbers, just the expression. Yeah, exactly. It's FC minus W. Now let's look over here. What is my tension B? Exactly. So I was shocked about this too. I always used to think that tension is something that always remains constant, that always remains the same. But that's not true because now we know that, basic physics, we know that according to this, and we cannot even say that this is wrong. We know this is right. So tension at A is Fc minus W. So, um, can anyone tell me what would this look like if this were? What if I place the formulas? What is the formula for W? Come on, what is the formula for W? And what is the formula for FC? I want to express this in formulas. What is the formula for? Yeah, it's mg. So minus mg. And what is my FC? I've been teaching you guys for a few days now. What is the formula for centripetal force? Yeah, it's mv squared r. So we're just going to use mv squared over r, but you can use that as well. So mv squared over r plus mg. So now you know that tension A is not equal to B. This is not true. So let's make a few notes. Let me make this smaller. Okay, I'm going to make this smaller now. So now you know that whenever you have weight, the scenario is not really the same. So let's make these notes. And yeah, you guys are going to have to write. So tension at A is smaller than tension at B. Now, I have a little question. Let's say I'm spinning something heavy. Okay, so let's say I'm spinning something heavy. It doesn't have to be something heavy. Let's say I'm spinning a ball, right? Okay, so a question: if the tension at a certain point in circle be higher, oh, we obviously would feel it, but we would feel it. You know, when I was spinning the bucket, it was actually harder. Yo, if anyone has the mic on, please turn it off. Okay, great. Okay, so when I was spinning the bucket, it was easier for me to spin the bucket when it was over here because the tension was lesser. But it was harder for me to spin it when the bucket was down here. Normally, we would think, okay, so I think that this is, yeah, I was about to ask it. Okay, so, but I'm still going to ask it. I'm not saying that this is right. So, what point has greater chances of my rope breaking? So, which of these points has the greater chances of my rope or my string breaking? Come on, I need an answer from everyone. What do you think? Which one of A and B has greater chances for my string or my rope to break? Exactly. Now let's write it down. By the way, it's a very important point. There's a question in past papers about this as well. So the probability of the rope breaking is highest because, okay, I'm writing this to answer Ima's question as well. So the probability of the rope breaking is highest because of tension is highest. Let's add at A, B. Let's add at B. Okay, just a second. Let me use a different color. So at B because of greater tension. Okay, so Ima, what is tension? Isn't tension a force that kind of pulls or pulls the rope? So let's say I have the string. So what is tension? So let's say my string is this, and let's say this pink part is me trying to extend it. Okay, just a second. So this is my string, right? And this red part is me trying to stretch it. So I'm stretching this the string. Now tell me, which one of these scenarios has greater tension? The pink one or the extended one? So when my string is extended or when my string is normal? Yeah, the smaller string. So the smaller string has lower tension. It has lower tension. But when I stretch it, when I'm stretching the string, it has greater tension, right? I'm gonna read that later. Just give me a few seconds, Gautam. Okay, so now my string has greater tension, right? So if my tension is greater, we also know that when we stretch a string, there's higher chances of me breaking it, right? When you stretch a string, obviously, I mean, you expect it to break at some point. That's why you are very careful when stretching a string, right? Because you can break it. You can break it because of higher tension. So when you have greater tension, there's greater chances of the rope breaking. So that's why at point B, because I have greater tension, my rope has greater chances to break. Okay, now let's read Varun's. Okay, so is it clear, Ima? And meanwhile, I'm gonna read Varun's question. No problem. Okay, let's read. Okay, so since it's a uniform circle, and since you told us that the centripetal force is greater, the further away from the center you are, isn't the tension the same T both points? Okay, so Varun, that's a very good question, but the problem is, before I didn't talk about weight, I didn't talk about gravity, did I? All of those scenarios, well, were horizontal, right? I mean, a turntable is not vertical. A turntable is horizontal. But this is a vertical circle. And in vertical circle, stuff is different because now we have gravity. So all of the stuff we did before, that was conceptual and we didn't consider a lot of factors. But now we, you could say we matured and we started talking about more things. So I hope this is clear. Yeah, it's a different situation. So please note it down. No problem. Please note it down. And we are going to do one more thing. I'm really sorry. Today's class has to be a bit longer because yesterday's class was smaller due to internet connectivity. So it's going to be a bit longer. I just hope you guys don't, fall asleep or something. So note it down and let's do the horizontal circle. So has everyone noted it down? I see one of you has, but what about the rest? Come on, we have like 16 people here. Okay, that's amazing. Okay, so I'm clearing the. Okay, now we just did the vertical circle, but there's a continuation to this concept. We haven't finished it yet because now we're gonna do the horizontal circle. Yeah, sure, great, amazing, good job. Okay, so horizontal circle. Now, this I hope the circle looks nice. It looks terrible. Anyway, it doesn't matter. So I again have a string right here. Let me make a string and let's say, okay, I guess I'm gonna have to make a circle. You're right, Bottom. So Usman, you missed today's lecture or yesterday's? So no problem, you can watch today's. Okay, so uh, I'm recording everything, so you can watch it later. Okay, are you talking about when I clicked the record button, right? So when I clicked the record button, you missed before that, right? The second part of the lecture. So don't worry, it wasn't really anything important. I was just talking about the washing machine. It was just a conceptual thing. So don't worry. These are the main concepts that you're supposed to know. Okay, now I am again spinning a ball with a rope. Can you guys tell me what is providing my centripetal force? Now this is a horizontal circle. We don't really have weight, do we? I mean, we have, but what do you think, guys? What is providing the center? Yeah, obviously. And the tension is going to be towards the center. So in horizontal circles, we don't have, I mean, there are other forces, but at our level, at A2, it isn't it isn't really that important. So I'm gonna write it here. So ignoring, oh, thanks Sabina for sharing. So this was one statement only. So the guy who missed the thing. So basically, I just mentioned that statement and that was all. But I did show it when the recording started. So if you didn't know, now you know. Okay, so I'm gonna write it here. So ignoring vertical forces. So we know that tension is equal to Fc, and this is basically our Fc. Now, there's another very interesting thing that I'd like to share. I talked about it before, but we're just going to talk about it one last time. So horizontal circle is not a conceptual thing like vertical circle, but it's more of a example thingy. So we have Earth and we have Sun. So this is my Earth and this is the Sun. Can you guys tell me What is providing the centripetal force now? Now this is something huge. I mean, what do you think? What is providing the centripetal force now? And by the way, this is also a horizontal circle. This is a horizontal circle. I mean, it's an ellipse to be honest, but we we classify it as a horizontal circle. So what do you think, guys? What is the legendary centripetal force here? So Sabina, correct answer. The gravity is providing the centripetal force. And the amazing thing is, uh, soon we're going to study a chapter on gravitation, and it's going to involve a lot of these concepts. So let's write it down. So, force of attraction. Earth is, okay, let me just rephrase it. I'm sorry if anyone was writing. So, gravitational force, exactly, you didn't know? The reason our Earth and all of the other planets, they are in this solar system, it's because of the sun's gravitational force. This is the gravitational force, and this is providing the centripetal force. Okay, so gravitational force provides the centripetal force. Centripetal force. And this, on this one statement, a whole chapter lies ahead. So Fg is equal to Fc. So have you guys noted it down? There's a little bit left and we are going to be done with this chapter. But obviously I have to, you guys can note it down. Meanwhile, I have to say something important. Whenever you're studying A levels, do not expect to ace your papers just by taking lectures, because this is passive learning. You are listening to the teacher. You're not practicing on your own. So my advice to all of you is, there's these books, they're called the topical past papers. So either find online, if you need online, we can share in our group. So either solve those or go to a shop if it's open. Yeah, I'm going to send the link later. So do solve the topicals on weekends or whenever you have time, because if you don't solve the topicals, so you're studying a concept over here, you open the book and you're like, bruh, but I learned that. What is this? I know, right? Some questions are like that, but obviously don't worry. What I'm teaching you is inshallah gonna help you in the questions. Okay, so I'm gonna clear this. No problem. I can just share the link. Okay. Now, in addition to the vertical circle and the horizontal circle, we have a very interesting concept, and it's called the conical pendulum. No problem. It's called the conical pendulum. Okay. So you guys have been studying the normal pendulums, right? It oscillates like this, but now it's a bit different because, so let's make a normal line, a normal line. Okay, so Lisa says, I thought people float in space because there's no gravity. Look, that gravity that attracts planets and doesn't attract humans, it's different. It doesn't work the same way it does for humans. So what that is it's a gravitational force. And that gravitational force, it attracts the planets and it causes the planets to spin. So it's a bit complicated, but basically it's not the same that we are experiencing right now. But all of them are FG. So we have a conical pendulum. So I'm making a normal line over here. Okay, it looks bad. Let me erase this. So I have a conical pendulum and I am moving in a circle. So I hope you guys can imagine this. It's the same, it's a similar scenario to the one where I was spinning like a Tarzan, something like that. Okay, so we have the ball and this is our theta. This is our angle theta. Now, What is providing the centripetal force in this scenario? Come on, guys. What do you think? What is providing the centripetal force in this scenario? Okay, so Varun has an answer. Anyone else? Because I need to know what you guys are thinking. It's kind of important. Come on, everyone. Don't worry if you get it wrong. The weight, tension, weight, tension. Okay. So for starters, we know that tension is acting over here, right? And we also know that if I had a centripetal force, it would be acting towards the center. Now tell me one thing, Varun. Is my weight acting towards the center? Obviously, no. I mean, my weight, it's acting downwards. So anyone who said weight, I am sorry, because weight is not providing the centripetal force. And if anyone said tension, you are kind of right. Now, you are studying AS and you did O levels, but it goes more with AS. You guys studied that tension has two components. Can you guys tell me what is going to be this component? Is it going to be T sine theta or T cos theta? Exactly, it's the component. So which component is it going to be? Exactly, T sine theta. So this is going to be T sine theta. And there's another thing. This ball, when it spins, right, it stays at this level, right? It doesn't go up and down, right? It doesn't go up and down. It stays where it is. Well, it's because this component, T cos theta, now it's a very interesting thing. W, or weight, it's equal to T cos theta. And that's why the ball stays where it is. That's why it doesn't move up and down. That's why it moves only horizontally, because it's W is equal to T cos theta. So this is an example of the horizontal circle. So let's write the explanation because it's kind of important. So that's why the pendulum does not move up or down. And we also know that T sine theta provides FC. Okay, guys, so I have a little news. So I was gonna finish the chapter today, but the second meeting is about to end in 2 minutes. So please note this down. And yeah, I guess we are gonna have to end the lecture because having a third meeting for the same class is not too cool. Okay, so does anyone have any kind of confusion in this question? If anyone has, you can ask me now because we have 2 minutes left, and then the meeting is gonna end on its own. So I'm gonna share it in the group, the channel name. It's Lear Academy, and we send links in the groups on Discord and WhatsApp. Okay, guys. So tomorrow we have literally almost finished the chapter. We just have We have two small things to discuss. Yeah, I can repeat it tomorrow. Don't worry. I can talk about it tomorrow. Yeah, you didn't miss any much. You didn't miss much. So tomorrow we are gonna do some questions. I'm not gonna do past papers, but we're gonna do some questions tomorrow, and we're gonna finish this chapter tomorrow, and we're gonna do some questions. So have a great evening, and I hope you understood everything today. The video is gonna be uploaded by tonight or by morning. We haven't discussed about the tests yet. Once we discuss, we are gonna tell you. For now, there's not gonna be tests, so don't worry. Yeah, the worksheets. We're gonna update you about all of that. So anyway, guys, have a nice evening and Allah Hafiz. I'm ending the meeting. Bye.